So we started with this warm-up question, and the red stuff is right here, and the blue stuff is this. And then we talked about how there wasn't any symbol, and I gave the kids permission to know that if there is no symbol, that means that they want both of those things to be true, and therefore the intersect. So if there's no symbol between them, you can count that as an intersect. All right, let's move on. Today, one of the things you really need to understand in honors pre-calc is this, and I said it before, and you seem to listen to me, so I don't know. If they tell you that you've got the y-intercept, what did I say you're supposed to know about that? Not like it's a dot that's on this y line. No. The y-intercept means that, don't say it, hold that thought. Nobody seems to be remembering, I'll say it again. The y-intercept that means that, Anya?
When x equals 0, it's that y.
So wait, let me see. The y-intercept means that what?
So when you plug it into the equation, you put a 0 in the equation for x.
Yes, x is 0. And the x-intercept means that, Olivia?
Y equals 0.
Y equals 0. That's super critical. Because I know you look at them and you're like, duh, it's this point right here. But the y-intercept it's critical that you know that the x is 0 there. It's 0 comma something. And the y-intercept, it's really critical that you know that the x-intercept is where y is 0. I put the 0 in the wrong spot. And the y-intercept is where x is 0. So it's 0 comma something. That helps a lot when you have an equation like this. X squared plus 6x, y equals that. And they say, hey, where's the y-intercept of that? And a lot of people would just be lost. But if you think about what we just talked about. If I said, what's the y-intercept of that? Well, I can just put in x is 0. And what's y equal to then? 0. See how quick it is to find the x-intercept and the y-intercept? I'll give you another one. Y equals x squared minus 4. What's the x-intercept of that? Immediately, I hope your brain kicked in and said, oh, that's where y equals 0. And you put a 0 here. But it doesn't become instantly clear. But if you can factor it, you should. If you can factor it, you should. I want you to finish it for me. If you can factor it, say it. You should. X plus 2, x minus 2. And all of a sudden, it becomes clear. Oh, yeah. X must be negative 2. And what is that again? It was an x-intercept because we set y equal to 0. So that's the x-intercept. And this is another x-intercept at x equals 2. Okay, so the intercepts are super important. Moving on. The Venn diagram lab. I want to remind you that there are several sections that are required. You must write the word purpose in your lab. I know some of you haven't even started. I totally understand. It's not due until next Wednesday. The test is Tuesday, and the lab will be due Wednesday. That way you'll have the night after the test, if you want to finish it up. I will tell you that sometimes the lab questions are on the test. So do you get how it would be smart to take and do your lab as you're getting ready for the test? Because, you figure that all out. You got to do it anyways. And if you do the lab before the test, you might be helping yourself with a better test score. But it's not actually due until the day after the test. That way I know you have one night where you had no other homework because, all you had was the test that day. So this lab needs a purpose, and you just need to say it in your own words. It needs a sketch. It needs a procedure. It needs a calculation, and I prefer those to be separate. And then it needs the conclusion and the reflections. I call them reflections. And you have to have 3 reflections. I want you to think about what you learned. Like, I'd never done that before. Or I never had thought of this that way. I want you to be thinking specifically about what you learned. And sometimes it might be in a case like this where you're just doing something fun and interesting, but to you, where you're polling people, you might be just surprised at the results of the poll. Like, I didn't know so many people were scared of robots or whatever. All right. So be starting on that lab, and a good lab write-up, again, it starts with the title of the lab. Okay, and this is the Venn diagram lab. And then it just leads right off with purpose. Colon. My purpose is to blah, blah, blah. If you type it, I will say you tend to get better scores than if you handwrite it. Okay, so my is not off to a beautiful start here. You should type it. You don't have to be like amazing, perfectly formed sentences and everything.
To get a good grade.
But if you're, no, your purpose in the lab is to explore something. In this case, make it the Venn diagram that includes the opinions of my friends, and then write some questions about it. That'd be a good purpose. Yes?
If we've been handwriting our lab and we have like somewhat neat handwriting.
If you have neat handwriting, it's fine. There's no like specific, did they handwrite? Take off 2 points. It's not like that. It's just, if it's crisp and I can read it well, it's going to get a better grade than if it's really sloppy. Because it's just going to be a tendency of the teacher to go, this kid really didn't try that hard because it's really sloppy. Crisp. All right. Some helpful graphing principles. Get to this page, please. So equations of vertical and horizontal lines. I get it all the time that people are like, is this at 5 this way? Or is this at 5 this way? And I could see how you could easily be confused by that. So I want to remind you, this is the x-axis and this is the y-axis. And I can see how you could get confused by that. So I think you should always just go like this. Go to the spot where x, on the x-axis, where x is 5. So just count over to x is 5. 1, 2, 3, 4, 5, and put a dot there. Clearly it has to go through that. And then you'll pretty quickly realize which way it goes. You know what I mean? If it has to go through that, it can't go the other way. I mean, this is the only way to keep x 5. Otherwise, x is going to be 4 and 3 and 2 and 1 and 6 and 7 and 8, and that doesn't make any sense. So if you have to graph y as -3, first go to y as -3 on the axis, and then you'll pretty quickly realize, oh, it must mean this way. You know what I mean? All right. But there is some dissonance there. This one's a y equals line, and it's in the same direction as the x-axis. Look. The black, here, I'll erase this other one here. That's the x-axis, but the y line runs the same way. Well, the way you can remember that is the x-axis is where y equals 0. So the x-axis is the line y equals 0. What's the y-axis? The line where, what? X equals 0. Okay. Moving on. I want you to get to this slide. And now I want you to turn your iPads my way. Thank you. Charlie, get there quicker next time. I think you were distracted. Thank you. All right, good. So, ready? Sketch a function with no x-intercepts. All right, so I go, okay, that x-intercepts, so there, I just sketched a function with no x-intercepts. What's wrong with my function? One input would have 2 outputs. In fact, I could even make it 3. So that doesn't pass the what? Vertical line test. Not straight line, vertical line test. All right. So I was close, though it didn't have any x-intercepts, but it wasn't a function. Okay, so make one with... And do these in the colors that they show. So make a black one that has no x-intercepts. Make a red one that has 1 x-intercept. Make a green one that has 2 x-intercepts. And these are all functions, so they have to pass a vertical line test. And last but not least, the blue one, no y-intercepts. You might be thinking, how can you do that and keep it a function? But you can. So Charlie, what are you going to be playing tonight? Is it what? Excellent. What's your favorite pattern? Is it a post? A lot of people like the post, but what? Okay. On your team, if you do a button hook, you go up, turn around, is it at a high enough level that the ball is already in the air before you turn around?
Yeah, I have a playlist where I do a button hook, and then the corner goes down, and then I run straight, and then they throw it on.
Ooh. I hope that gets called. That'd be cool. Okay, so here's one with the X or no X intercept. Here's one with one X intercept. Yours going to look totally different than mine, but here's one with two X intercepts, and it's got to be green. All right, so there, it's got two X intercepts. And last but not least, no Y intercept. That's harder. Anybody have any thoughts? Because you can't have a straight up and down line. As soon as you have a straight up and down line, it won't pass the vertical line test. Yeah, Mira. Can you show me what yours look like?
I kind of messed up on number 2, but...
All right, I see what you're doing. She's going like this. The problem with this is you said parabola. So then I know that thing does keep getting wider and wider and wider, and eventually it would cross. I just can't see it right now. And Anjali.
You could do an exponential function that has enough asymptotes at the
Ooh, she said the magic word, asymptote. Asymptote is a dotted line, and it looks like this. And if the asymptote is right there on the y-axis, which would mean it's at x equals 0, then you can draw your function in a lot of different ways, just showing that it gets closer and closer to that but never touches it. There are multiple functions that will have asymptotes like that, and usually they are fraction functions. It'll look like this, y equals 1 over x or something like that. Okay? There's more than one way. All right. So the key though was there'd be an asymptote there. That's why it would never cross there. Yes?
Would you also be able to do a square root function?
Square roots can be 0 though.
And then like translated.
Oh, a translated
Yeah,
square root
like
function.
this.
That could work. The regular square root function starts at 0, 0, so it technically doesn't qualify because it has an x and a y axis or intercept at 0, 0. But then you said translated, so moved over a little bit. Sure, your square root moved over. That's a great idea. Okay, moving on. Types of symmetry. X-axis symmetry, y-axis symmetry, and origin symmetry. I want to give you the simplest ones here. First of all, let's light up the x-axis. That's this one, right? So that's got to be our line of symmetry on this shape. Now, if it has x-axis symmetry, this is one of the most famous things that has x-axis symmetry, but it's not a function. You know why? Yes? Doesn't pass the vertical line test. Very good. Okay, so that is not wrong, though. It has x-axis symmetry. So functions are a great thing, but things that aren't functions, they're called relations. It's not like they're illegal. That's a real thing. It's just not a function. So you go, in case you didn't know, y equals x squared is a normal parabola. And that has y-axis symmetry. But I said that so that some smart kid could probably figure out the equation for that sideways parabola. What do you think? Boom. Did you take this class before? X equals y squared. It gives you that sideways parabola. Not a function, but it has x-axis symmetry. All right, and then the last one is origin symmetry. A lot of people aren't going to know this one, but you've probably seen this function before. Do you remember the one that does that? Y equals x to the third is an example. There's a million, but that's a common one that has origin symmetry. Now, the others are so easy to see. You're like, here's this line that runs right down here, and it's exactly the same on both sides of the line. Origin symmetry is more complicated, but here's how it works. If I have the point 8, 2 on this graph, I know that's not exactly what it is. I'll make it what it is. It's more like 5, 2. Then it would have the point that when you go through the origin and you make a straight line right through the origin, it would have to have the point -5 comma -2 on it. Now, I didn't draw mine perfectly, but if it had perfect origin symmetry, if 5 comma 2 is on it, then -5 -2 has to be on it. You go right through the origin, and it takes both x and y numbers, and it makes them both negative. Yes?
So then would y equals x?
The line y equals x. Good question. This line, y equals x, would that have origin symmetry? Is that what you're asking?
Yes.
All right. Fair question. So if I take any spot on it, so like 3 comma 3, do you think that I could draw a straight line through the origin and go to the other spot, which would be exactly the opposite, -3 comma -3? You tell me. You think it has origin symmetry? Absolutely it does. Good.
Then wouldn't, like, any line that passes through the origin,
Okay, fair question. Does any line that passes through the origin,
that's a function?
that's a function. Okay, now that's a, not any line, because I could do this. Oh, pass through the origin.
Doesn't a line that's a straight
Oh, wait.
line go?
I did actually fail the vertical line test there, but any straight line that passes through the origin
Isn't
might
that
be a
what
right
line
answer.
means? Like, if you say line, doesn't it mean?
Good question. Nope. If you say the word linear, then that's straight line. But a line can have a curve.
In a linear
It's
line.
important to be, it's important to be clear. So a linear function is a straight line. A non-linear function is a curve. Okay, so let's get back to, you were asking like, could I do another straight line that goes through the origin? So here's how I would test it. If I take this point and let's say it's 10 comma 2, would it be able to go a straight line through the origin and hit -10 comma -2? If that's the case, then your line works. I just don't want to make too many generalizations, because if you say all of this kind of thing, it's dangerous, because usually the answer is no. You know what I mean? Like things that use the words all and never, they're usually wrong, because there's usually an exception to the rule. Okay? Yes?
Straight lines have 180-degree rotational symmetry, so I think, like, basically every linear function should have origin symmetry.
If
It passes through the origin.
Oh,
if it passes through the origin. Yes, you never said that. So I'm just, see, that's an example of like, seems like a really good, true statement, and then you realize, crap, I didn't define the one other thing. It has to go through the origin. If it's a straight line going through the origin, then I think you're right. But I really avoid alls and nevers, because it's so hard to say it exactly right and not have an exception. Okay, here's the main point. If we give you a graph and we say, does that have y-axis symmetry? Should look at it closely and decide, oh, that's pretty easy, isn't it?
No.
Because here's the y-axis, and it's have to have the same exact thing on the other side over there, and it doesn't. So this does not, for sure, have y-axis symmetry. Does it have x-axis symmetry?
no.
No. What's it closest to having? Origin symmetry, where you could grab something from here, go through the origin, and there's something on the other side, but it doesn't look, it looks like I'm going to have to fake it a lot, so this doesn't even have origin symmetry. All right, so you tell me, what does this have? Don't say it, write it. Yes.
On the problem before,
Yep.
that one wouldn't have been a function, right?
Did it fail the vertical line test?
Yes.
And remember, though, I don't want you to think that that means that the answer is always, there is no answer. I can draw things that aren't functions, and you still can tell me what origins or what type of symmetry they have. So we a lot of times will put like a circle on it and ask you to think about what kind of symmetry it has, even though circles aren't a function. So you're right that it wasn't a function, but that doesn't mean that it's disallowed from this class. We do lots of things that aren't functions. Is this one a function? Looks like a function. Looks like it passes a vertical line test.
Except for the arrows.
Now there could be, well, the arrows aren't part of the line. It's just a direction that the line's going. Now, if it had asymptotes here and here, would that change your opinion about anything? Nope. Kind of looks like it has asymptotes as it is. All right. So do you feel like this one has x-axis symmetry? No. Y-axis symmetry? No. Origin symmetry?
Yes.
Yes, as long as you're generous with, like, I didn't draw it perfect. If I go through here, there's a point on the other side, and it would be the opposite. So if this was -3, 5, this one would be 3, -5. Both numbers change to the opposite of what they are. Yes?
So in like a relation like x equals y squared, like what like situations in life would you use to graph that?
Like that?
What cases, yeah. In what cases would you just do that?
Oh,
That is the question.
it's a good question. I want you to just know that there are a lot of, like, there are a lot of functions that you also wouldn't ever see in real life. But I bet you if I gave the smart kids in this class a chance to think for a while overnight about something in the real world that does this, they could probably figure it out. You got one already?
No, what I was wondering is, x equals y squared, since it doesn't pass the vertical line test, it isn't a function.
Correct, not a function.
So what is an example of a function with x-axis symmetry?
I can't give you one. That doesn't mean that there isn't one, but I can't think of one. So, yeah, you're going to have a lot of things. I'm trying to make this really clear. I may have pounded on the function drum too much because now some people think that everything has to be a function. There's a lot of things that aren't functions. Like this is not a function, but it has all kinds of symmetry. What kind of symmetry does this have?
X, Y, and origin.
X-axis, Y-axis, probably, and origin symmetry too. All right, yes?
Could like a function where it says that y equals something have x-axis? Wait, no.
If it's solved for, it's actually an interesting point. If you solve something for y, and it's got an equation like x squared plus 6x minus 7, any function solved for y, if you can solve it for y, then it is a function. That's a fact. But if I solve something with y squared equals x, then when I solve it for y, I go like this, I get the absolute value of y, and I end up with two functions, y equals square root of x and y equals negative square root of x. And that means that this line right here is actually made up of two functions, one that goes this way, another one that goes that way. You can put two functions together, and now you've got something that is not a function when you put it together. That's all the time I have, though. You guys could ask all kinds of great questions for the rest of the hour, and unfortunately, we don't have time. You can always ask me more questions when we hit the last 10 minutes. All right. I don't think I want to play graph puzzles, so we're going to move on. Here, oh, look at that. That's an assignment. Ever heard of those? So let's actually do a few problems on this topic. And this is weird. What the heck is going on here? Now it says graph the given relation. Does that mean it's not a function? No, because all functions are relations. So then they say relation, they're using a generic term that means it could be a function or it could not be a function. So let's actually get the first few points on this. Would you guys tell me a point that is on this? Yes. When you put in k is...
When k is 1,
Okay, if k is 1, then you get
6,
6, 1. When k is negative 1, you get what? Comma. K is negative 1, right? So negative 1. When k is 2. Now, do you have to actually, like, graph all of these points? I'm not going to be like, oh, you skipped 4 of them. You need to start seeing what it looks like, though. Okay, so I do need to graph this enough so I can see what's going on. So I go 6, 1. It's a dot. Oop, missed. Right there. And then negative 6, negative 1. Negative 6, negative 1. And now I'm going to go, k is 2, then I'd have 6 over 2 is 3. And k is 2 is 3 comma 2 over 3 up 2. I still haven't figured out the pattern yet, but I'm going to try k is negative 2. So I put in negative 2 and I get negative 3, negative 2. Pretty soon I'll see the pattern. Oh, I see what's going on here. And it looks to me like it's going to have different kinds of symmetry. And that's probably why they're having me do this. All right. And there's also, maybe there's going to be horizontal and vertical lines in here somewhere. All right. Now, symmetry tests. I want to talk about those just for a second because that's the last topic I haven't covered. So how can you test something for symmetry? So say you had this function, and you suspect it has y-axis symmetry. Would you agree, looking at it, it looks kind of like it has y-axis symmetry? Okay. Then if you take a point on it of 3 comma 2, you should test and see that what would be on it. Negative 3 comma 2, right? So what's the test here? If that's x and that's y, if you put in negative x, you should still get the same y. Does that make sense to you? This compared to this, the one's negative. So if you put in x, you'll get y. If you put in negative x, you'll still get y. That's y-axis symmetry. F of x gives you y. F of negative x still gives you y. Let's talk about one that has x-axis symmetry. Like here's one that has x-axis symmetry. Oops. Say I have 5 comma 3. What would have to be on it if it has y-axis symmetry? What comma what? 5 comma negative 3. So if it has x-axis symmetry, you'll have this situation where you can either have y come out or you could have negative y come out. F of x is equal to y, or f of x comes out to negative y. And the last kind of test is if it's got origin symmetry like this, and you had the point 5 comma 3 on it, what would have to be down here? Negative 5, negative 3. So then this is like f of x equals y. Just you got your point xy, you stick in an x, you get a y. But when you stick in negative x, you get negative y. Okay. So the reason that those matter is I could say, imagine a world where I give you a function that starts like that, and I say it's got the point 9 comma 8 on it. Do you get that if you wanted to create the rest of the function, it wouldn't be a function actually. The rest of the graph, you could make it have origin symmetry still, couldn't you? That would mean you'd have to go down here somehow and be like something like that. Probably just did that wrong. Yeah, I think I did. Oh, this can be really hard. But I can tell you this. What point would have to be on that one down there? Negative 9, negative 8. What if I made it have x-axis symmetry? A lot easier. sorry, y-axis symmetry. Then it would have what point on it? Negative 9, comma 8. And then what if I had made it have that kind of, it's terrible, but that kind of symmetry? It would have to have what point on it? 9, negative 8. Okay, good. Those are the tests. All right. So, some homework. These are still basically a review problems of the previous. Okay, so I don't feel like we need this many, and that's just gruesome. So let's cross off this one. I think you should do this one. I think you should do this one. On the previous page, I'm okay with you just doing the first problem on that first page. Then do these two. And describe this is basically asking you to write the equation for it. You definitely need to know how to do this. So let's have you do 22 and 28. Those would both be good ones. So basically, I used to give you the equation for it and then you'd have to graph it. They have graphed it. You have to write the equation. So this, you make your set thing and you say it's all the points x comma y. If it's ever a 3D graph, just start with that. And then you just got to figure out what to put here. All right. That's a fairly reasonably sized assignment. And I don't know if I'm going to put up a Dropbox or not. And this might be the first time where when you come back tomorrow, I'll say, okay, everybody take out your homework. Dropbox it first. And why would I have you Dropbox it before you grade it? So you don't cheat. Because otherwise you could be just writing in the answers as I say what they are, right? So I say Dropbox it right now, and then we'll grade it, and you'll Dropbox it again. So then I can see what it looked like before we graded it, and what it looked like after you grade it, because kids are less likely to cheat when they've got in the same Dropbox the proof that they cheated. You know what I'm saying? Okay, so bottom line, just come with your homework done. I made it very small. All right, and maybe we'll show you what that's like to grade your homework that way. All right? Okay, so even if I didn't post a Dropbox tonight, when you come to class tomorrow, I could say, okay, right now, I just put the Dropbox up. Dropbox it now. Okay, so bottom line is you should do your homework whether or not I'm going to grade it. You should be doing it. So you shouldn't have to be like, well, but there wasn't a Dropbox, so I didn't do it. Bad answer. Okay. All right, that's all I have for the video for today. Unless there's a question. Is there a question for the group? Okay, good. That's all I got for today then.